Hello there, grade 12 math fans. Mr. Restall here. Who else would it be? Um, this is a short video where there's a type of question that comes up and where it's a kind of a strange formula, too many variables that we're used to. We're used to an equation that has a y and an x and then maybe some numbers around that makes it a certain type of function. But we have these questions where there's too many variables, and then it asks us, what would have to be constant to get a linear function, a quadratic function, or an exponential function? Well, a nice way of handling this, and this was actually um, shown to me in semester 1, 2017 by an MAP 4C student, is using DESMOS. So DESMOS is that great graphing tool, but I'm going to actually just type in exactly what you saw. We're used to graphs where y is on the one side, but I'm going to type it in exactly as it appears. I, and then to the exponent n, and then it asks to add a slider. The slider is actually allows us to make some numbers. So for instance, if I click on, we want C to be a slider, then C would be, these numbers, 0.9, or I could make it 1 or 2 or whatever. But the problem is I and n are both variables still. So I still need to make one more of them a constant. So C is a constant 2.4, and let's make n another constant. And see, then I becomes kind of like the x, right? With an n of 1, when if n of 1, it looks like a linear function. So if we wanted to use that as our answer, we could go back to our question and say when n is 1 and c is 2.4, we get a linear function. But watch this when I change n. Oh, it's very strange, isn't it? And look, right there. If n is 2, if the exponent is 2 and c is some other value, doesn't matter, then I get a parabola. It's a quadratic, right? Which I is left as the variable. I kind of like becomes the x. H is always going to be our y variable. And then when we put a slider in, they become the constants. So that would be a quadratic. So back to our question, do this question. Quadratic function would be n is 2 and c is 3, and then I is left as one of the variables. Okay, so how do we make an exponential function? Well, an exponential function, we know that the n has to be the variable. So I'm going to stop this being a slider, and I get a choice here. So if n needs to be the exponent, I'm going to make I a slider. Well, that doesn't look like an exponential function, but let's move I. Well, there's an that looks like a familiar exponential function, and I can change my initial value there just like we're used to. And I'm getting emails there. And it's an exponential function. Watch what happens as I make I go to a fraction. All of a sudden, exponential decay. Okay, so that's a cool way to answer questions like this question. And they come up in a couple of different courses, so you might not be in MAP 4C watching this video. You might be in some other course, but this question does come up. See, I told you, short video. That's it. Have fun with the Desmos.